free for any Audible members. So I was like, I'm going to listen to it. So I did, and I learned a lot. So solid is meant to keep object-oriented software understandable, flexible, and maintainable. But when we do React Hooks projects, we're not doing object-oriented code anymore. We're doing functional programming. So we can apply it to React, but it's a little bit different and it takes some thinking, really. But we can achieve similar results. We can achieve React code that's understandable, flexible, maintainable, and lasts over time, which is the best, right? We've won when we have built something that lasts the test of time. So solid, it's one of those acronyms you hear try, you hear solid, you hear all these things. Just fitting it into the big picture. It's book 2 of Robert C. Martin's set of books. Book 1 is clean code. And that book covers how to write really good functions, how to write files that are easy to understand, how to make your variables and set your loops. It's small scale, so it's really easy to talk about the one thing at a time. Solid principles are a lot larger scale. It's about structuring your repositories and how do they all fit together when you have multiples. It's about setting up easy to understand libraries and ones that stand the test of time. It's about awesome release parties, right? It's not about a function or a loop. It's about the big thing. And when we do React, when you start a new project, like if you do the Next.js or the Remix, starter project, they don't give you a file. They don't give you a function and say, start coding. They give you a whole repository, and then you have to understand it and then move into it. And so this is kind of the same thing where we're talking about the bigger picture. And I don't know if you've ever spent a year coding something and you know everything about it, everything, where it is, and if there's a bug, exactly where that would be found. I was in stand-up today and I was like, there's a bug and this is the symptom, and somebody's like, oh, I know where that is. And they only do that because they just worked on it this month, right? When you leave for a while and come back, you forget those details. You hand it off to someone else. You try and train an intern to work on this code that you've spent 2 years on. Or something important needs to change and you need to completely redo how it's done. You have to figure out how to manage the mess. And so a lot of this is mess management. You want to work smarter, not harder, right? When we're trying to get something to work in class, it's not that hard to get it to pass the test, right? But when you get into a company and you start coding it and you need to get it right so that it lasts, that's a completely other matter. And honestly, I worked at multiple places. I've been a web developer since 1997. In a long time, almost 17 years. So it wasn't until 10 years ago when I started, 9.5 years ago when I started at Family Search, that I actually saw people advocating for getting it right. Getting it right is so important. I've seen the results in the maintainability of the code, and you can do a lot more with fewer people. And that's important to getting a company to be able to stand over time. Code design principles like solid and dry and all those are guardrails. Those are all about what not to do. They impose order and restrict functionality. It's easy to violate the principles because it's so easy to just throw something together and say, we're going to just work fast and break things. Have you heard of that story? We're going to work fast and break things. And then what happens is your temporary project becomes something that you have to maintain over time, and you're sorry, you have to move fast and break things. So it's often taken for granted that you have to get it right. But when you do that, when you get it right, instead of just ignoring the principles for the sake of speed, you end up with a completely different story when it a year or two down the road when you're trying to keep your company afloat. Because if your code base is too big, you need more and more people to handle it, and you can't afford it. And so that makes it hard to keep the company going. So the promise of clean architecture. When you get software right, something magical happens. It requires a fraction of resources to create and maintain. It's worth it, is what I'm trying to say with all these slides. So the benefits you get with solid principles are that your changes are simple and rapid. Defects are few and far between. Effort is minimized, and functionality and flexibility are maximized. So today I'm going to cover the solid principles. I'm going to do some component principles, which is covered in that book, and some of what clean architecture looks like. I'm going to focus most of the time on solid principles. And so solid's an acronym, so we're going to start with S. So S is the single responsibility principle. Every module should have one and only one reason to change. In other words, a module should be responsible to one and only one actor or stakeholder. So in React, what does that mean? A component should be responsible to one and only one user or stakeholder. So how many people will request changes to your module? That's the question the single responsibility principle asks. So let's take a look at a web page. In React, we build web pages. So this is the Herman Miller website. I got a new office and I did window shopping, and they had a 20% off sale. So I thought, oh, this will be a great example for us to look at today. So here, you have your cart, you have your order summary, your checkout section, all these sections of the code. So my question to you is take a minute and think about it. Answer, I'll repeat it. What people or roles might want to change what feature on this page? Any guesses? Is somebody at Herman Miller who might want to change a feature on this page? Yes.
Regulatory for sales tax in different states.
Yeah, let's say the sales tax rules change. That would definitely change something.
Marketing may want to change an image.
Marketing changes an image, yes.
Inventory.
Inventory, yes. All of a sudden, we want to be able to show that this has been sold out. Anything else? Any other stakeholders that might want to change something on this page? Any ideas? Go ahead.
The layout without changing.
Change the layout without changing functionality. You might have UX change. Let's say your company got bought out by a bigger company and they want a whole branding change. That's going to definitely change the page. So some of the thoughts that I had, or some of the same ones you had, UX might want to redesign the page. And how can you change the typography, the look and feel without actually changing the content or rewriting the page or making it so two stakeholders are competing for the same thing? Tax rules might change, shipping rules might change, sales information. A naive system might make it so, and I'm always testing the cart. So can I add a promo code and add it to my 20% off? Because I signed up to get 15% off and I tried to do both and they're like, nope, you can't do both. You get either 20% or 15, you don't get 35. And I was kind of mad, but some systems are just naive enough that you're allowed to fix that. So if we broke out these components so that each one has its own stakeholder, we might break out the sales tax or even the zip code. Like multiple people need to know the zip code, so maybe we'd share it, maybe we wouldn't. We might break out a design system so all the typography is written in React components, things like that. So here's an example from Family Search where I work with stakeholders. This is a field where you enter an ID. And we have this validator called isValid. It validates a tree person ID, a genealogies person ID, and an ancestral file person ID because we said, well, write everything once, not twice, and so we need to have the same function for all of these. But how many stakeholders then might change the logic? Let's say the tree person got really big and we ended up with adding a dash and 4 more numbers to a person ID. All of a sudden, Isabella Pig broke for the other 2 kinds of person IDs. So maybe we don't actually do it once and combine those. Maybe we separate them out because different stakeholders can mess up the logic. Even in the book, there were some examples of having multiple stakeholders when major finance problems happen in the organization. So, so the single responsibility principle, you might get hints of it being a problem in your code if you have lint errors, if you get the general lint errors. So here are some examples of what to watch for. If you see too many if statements, and then you look at it and you say, well, are more stakeholders going to request changes to this file? Maybe I should break this out into a different type of file. Maybe I can use composition or something like that, so each one has its own stakeholder. Or it's the same with this overly complicated switch statement. When you have conditional code based on some type that you pass in and you permeate your whole code, maybe there's a different way to construct your code base so that you only have one stakeholder and it's easy to change these. So maybe the first time you thought single responsibility principle was a function should do only one thing. When I went looking online for examples of React single responsibility principles, everyone said this. And in the book, he actually says this is misunderstood. It's a good principle that a function should do only one thing, but it's covered in the clean code book. It's not covered as the S in solid. Solid is all about the big picture. Functions do only one thing is about how to define a function. And so it's actually a completely different kind of area of the coding principles. But I'm going to cover it here because everybody else in React who thinks this S in solid means this covers it. So I'm going to cover it. When you have a function that's too big, here, what I always start with is JSX. You know, you read a function from top to bottom, so you think you might simplify the top first, but don't. Skip and simplify your JSX. Here we have 2 sections. We have this loading skeleton in the data section that I had to make smaller so it would fit on the screen. But let's just make a new component out of those sections. Here's another example. We have this collection list and we're mapping through them. Let's make a new component, or make 2. Make them inside of the map a component and the outside of the map a component. When you break up the JSX like this, and the hook section gets cleaned up automatically. Because when you move the JSX into a new component, the hooks that create that data move too. And if you have data in more than one, you can create the context or something, but it will still simplify it. And then you've got 2 simple components with simple JSX sections and simple hook sections. You have smaller components that are more organized and more maintainable. You've cleaned up the mess. When you want to extract, when you've done that, you've simplified all your JSX, then you want to organize the code up top into sections. Just move the hook code together. So how can I rearrange it so things that are similar in a similar box and then create custom hooks out of it? And that way you've made this component super easy to read. And if there's a bug, you know exactly where to go because it's named properly. You go into the hook that creates that one thing. Other indicators that you can look for that your function does too much are lint warnings, repeated code, component gets too long, or it just takes a long time to read and understand. If I'm given a bug to go fix a component that I thought was really good a month ago, and I come back and I'm like, oh, it's not as good as I thought it was, then it's time to refactor. So that is S in solid. O is the open closed principle. This principle is components should be open for extension, but closed for modification. So what does that mean in React? Open for extension, but closed for modification. Any ideas? Any thoughts here? What does it mean to extend a component or a module? Something in React, simply extend something. There's a multiple ways of extending something in React. We can use it. We can use composition to just use it, and we just put more code around it, right? And then we haven't modified it. But sometimes people are like, well, I need to change something inside this component, so it's time to modify it. But can we add to it without breaking it? So the idea is to avoid breaking changes. You can add features, but removing features is not okay. Design your component to grow over time with composition or prompts. I had a talk in October with another department of my company that I work for. And these departments are so different than, like, we don't know each other, and we don't share like login information to GitHub or anything like that. And so they said, well, can we share your code, this code? And I was like, what if we create something that is open for extension but closed for modification? We build this really stable image component that everyone can use, but we never actually break it. And that means we make sure we built it so that it can't be broken, and we set those rules, and then it will last forever. If it has no dependencies, and then it can last forever. And we found a way that we can probably do that. Avoiding breaking changes. So in Semver, it's the semantic versioning. You have the major version on the left, and if you use a package JSON, anything that you bring into that is it. You have your breaking change on the left, then you have your dot, your minor version, and then dot, your patch version. And so the open close principle would just say, don't do this. Don't have a breaking change. And yeah, you have to sometimes, but if you built your code well enough, you might not ever have to. I was looking on social media, and they said this is the proud semantic version, and on the left is the proud version. When you're proud of your release, then the default version is just a normal okay release. I'm not that proud of it, but I'm not afraid of it. And then the third one's the shame version. The bump when fixing things are too embarrassing to admit. And I saw this, and those of you who know me are like, yeah, I hate breaking changes, like absolutely hate breaking changes. So it's like, don't do this, please, ever. If you're proud of something, put it in the middle, please. It's just funny, but don't. Just think about the React code that you've written. Have you written any code where you read a component that you had to change the way it worked? So anything that called it had to change. When you changed that API, how many other components around it had to change? And it could have been in a package where I actually did a version, or it could have been in a folder in your main project. How many other things did you have to change when you did that? I was trying to like move this big like search results section into a component so that I could move it to a shared library. And I realized how many like touch points this API had with the other parts of the system. It was just like a spider going in. And if you set boundaries and set an API and you say nothing has to change, then you can prevent breaking changes. And just design with your open close principle in mind from the beginning. Now, how do you avoid it? Well, you create your components thoughtfully, enhance without breaking, be disciplined about changes, and don't remove props or features. But if you're like me or people that I work with, you end up with a component that's awful because we had to move fast and break things way back when, and now we look at it and we're like, it's horrible. So when it's time for that big overhaul, here's an idea of how to fix it. Make a new component deprecate the old one. Build your new component to avoid the future breaking changes, because you've experienced enough that you kind of know what's going to happen. And then the old one keeps working and you haven't broken anyone. Teams can adopt the new component early while you're working out bugs, or they can wait until it's stable. And then later, when you do that major release that you almost never do, you make a code mod so that people run that to change the API surface, and you can run it. So building for extension and substitution. This fixed button thing's going to come up a couple more times. We built a forward route in, which is a React thing to forward routes to the dominoes that you're using in your component. This tag name is pretty cool. You could use a conditional to swap out what component you're actually putting in here as needed. And so I was able to do something like this to say, well, maybe I want drag and drop, maybe I don't. And you can use the spread operator to forward your props to the children. So, yes.
How do you like to have components that are definitely able to practically like communicate and give people heads up?
Well, sometimes we'll just announce it. Just on the we'll add a new minor version that has the new component, and we'll say the other one is deprecated. There are ways to make it so your test, you can mark it as deprecated, like in JSTOP, and then test will warn you when it's deprecated. We don't like that as much to just send that out to anyone, because sometimes you say, I don't want logging in my test, and then your tests are broken just because you deprecated something. So you kind of got to walk that fine line, think about your users and how they act. But you just talk with them the way you normally talk with them. If that's a release page or if that's a channel account.
I look to follow React's internal docs, just change it all to like caps and just say like, do not use this or you'll be fired from your job. You can scour the React code and find that in there.
Listen, you can and should be logging. So just have a log message saying, hey, we noticed that you used this component. Please stop using it.
Yeah.
You can also use JS doc or something so that if they hover over it in the code, you could give them a deprecation, and there's a @deprecated in the JS doc stuff. You could use that, and then you can log a warn so that when they're actually opening up, I mean, that's what React does with most of their features. They'll open up the console and they're like, hey, you should maybe not do this anymore because we don't want you to. Like, oh, cool.
Yeah. It's not as unknown or as hard as it seems. It's just a new thing that we've got to learn, new pattern. Okay, so we're at L in solid. This is the Liskov substitution principle. Fun fact, this was Liskov is Barbara Liskov, one of our earlier computer pioneers. We have a few women in our computer pioneer history. And this principle is subtype objects should be substitutable for supertype objects. So what does this mean in React, and why does it matter? Has anyone run into this in React? Have you ever had substitutable objects? Maybe only if you write a design system. I don't know. My example is from a design system. React texts don't actually have inheritance like object-oriented program, but you can still have usage patterns where you've got subtypes and supertypes, the way you use things. You can substitute tags like that conditional I showed you earlier. And so sometimes you have components with a similar interface and you want those to be substitutable. Similar components should have consistent APIs and can be consistent with their base component. So this is an example of button substitution example, link name for trunking. So we have this design system where we have lots of buttons, and we added this thing called link name to our links. So if we had a button that became a link, then if you added link name, it would just do Adobe Analytics tracking. But then if you added it to something that was an on click, then you got a console error and it didn't do anything. And so this was where you couldn't really substitute. So this isn't how our button system is worked with all of our inheritance and everything. And can everything be substituted for a base button? Maybe, maybe not, probably not. There's probably a few extra bells and whistles we put on. But in the end, a base button was a link or a button. And so the button was plain HTML, link came from a component. And so the link accepted the link name and the button didn't. So I went to the team that built this. I wasn't on the team at the time. And I said, can we make this work? Can this be substitutable for anything that's non-to? And they said, sure, go do the work. And so I left the. So I went, and they not only that, but they said, you know, this might match for like these 5 other components too. So can you add it to all of them? Okay, so I did. But the idea is that you can maybe separate your component into many substitutable components. Maybe I could have done my search results data type thing in substitutable components with a base component. So maybe you can watch for a single component that with many different behaviors, but they're similar, many if statements and many return statements or a switch, and then ask yourself, can I build this that in a way that the components can be substituted and extended? And can I actually match that list-style substitution principle where they can be substituted? So I'm just bringing up the same slide as before. We talked about the link, the tag name, where you can have a link or a button. I think this is really powerful and we don't use it enough. You can substitute out a tag for any component, and all of a sudden you've got sister types. It's pretty cool. So that's L. I in solid is the interface segregation principle. Clients should not depend on interfaces they don't use. So what does that mean in React? We shouldn't depend on interfaces we don't use. When we're not object, we're not Java, we don't have interfaces in the same way Java has interfaces. What does that mean? Any ideas? So here's what I came up with. Components shouldn't depend on props they don't use, context they don't need, or an entire object when you only need one thing out of the object. That when I read the principle and looked at the examples, that's kind of what it boiled down to for me and what I could apply to React. Here's an example. I was working on a page where we had this dialogue, this mismatch, where you could say, we said, oh, this is a match. And they said, this is not a match. This has nothing to do with my ancestor. They're different people. And so we could just send, they could fill out this form and send it back. So we had it on our page and someone else wanted to put it on their page. We built it so that it would require this record context because we built our page and everything inside it needs a record context. And it's got 100 parts in it, but I only need 4 of them. And so what we did was we changed this component so it only took the 4 items and it didn't need the context. And all of a sudden it was reusable. We could even move it to its own component where it was completely separate from everything else. And it becomes a stable component that lasts longer and can be reused more than just the 2 times that we even thought about it. So this is one of my pages that I had found a couple years ago. And the purple is a context, and the green is a context, and the blue is a context. And so that button was, I think it was like somewhere in the green. I took out all the actual names, but if I went through, there are probably more items in this where I could have actually taken out some of the components out, and you can see up here we had a couple things that didn't have any context, but that was all we had. And I wish that next time I do this, I think I'll do it differently, just knowing that I interface segregation principle. So here's the D in solid. And this is probably the hardest one to apply to React. I wrestled with this one. It is depend on abstractions, not concretions. So what does that mean when you go to React, right? In Java, you have these abstract classes, and then you can depend on the abstract class, and then it just works with the concrete class. And then it becomes more general and works in a lot more cases than you originally built it. And so when we have React code, we can't rely on an abstract thing. So I really dug into it and to what he meant and why he said that. And this is what I got out of it. Prepare for and minimize the impact of dependency changes. So I don't know how many of you are in a situation like me and the team I'm on right now. Dependency changes and dependency problems are some of the worst things that we deal with. They're some of the hardest problems that we deal with because we write these codes, we write these components used in hundreds of thousands of places in our code base. And then we want to make a breaking change. And all of a sudden, some of these principles, it's like eye-opening. It's like, oh, this is why I shouldn't have done this. So this is what I really got out of it. Minimize the amount of code that's going to have to change when change happens. So you can solve this by abstracting things that might change. Let's say you have a library or a backend data format or something like that, and you're like, I know this is probably going to change one day. You can abstract it. You can minimize the prop drilling that you do from layer to layer, because when the props change, you're in trouble. You can encapsulate and abstract implementation-heavy logic using context and custom hooks. A lot of people, when I researched this to see how other React developers wrote about how they apply this principle, was abstracting libraries and encapsulating and abstracting things using context and custom hooks. That's mostly what they did. So abstracting data formats. If you have logic-heavy code, so this is an example, this function get person alternate names. I don't know how many of you have ever seen a gedcomex JSON file. It represents a family. Families are not as simple as you think they are, but represented in code because they get complicated. Anyway, so it's really a mess to try and figure out like what's in this. It's like, why is this a mess and why does it have to be this way? But it has to be this way until they change the format. And so I wrote this function that works with this format, and then you can call it. So inside my component that has all the UI, I just call this function, and in my library, I do all the hard stuff. So they're completely separate, which is great until they change the data format. There's a few ways to handle it, but it's either way, it's going to be hard. So you can create a library to read and parse the data, and then create a second library and swap them out if you need. And that's what we did in a world where global variables worked really well. But in React, global variables don't work really well. So find ways so you have less code to actually change. And you can use something called dependency injection, which is kind of a form of dependency inversion. It's mostly used in React for theming. Let's say you want to swap out a theme or you want to insert material UI or something. That's dependency injection with a context. And so we could do something like that. Prop drilling. This is an example from my Polymer days of prop drilling. This is just one section of like hundreds and hundreds of lines that look like this. We were passing prop to prop to prop to prop, and they're all slightly different. They all had to be perfect. If we missed one from one component to the next, there were like 5 levels and we were in trouble. So it was a mess. And so I hate prop drilling. And that's just my personal dealing with this. And so when I learned about React context, I thought they were awesome because you can sculpt them and you can have them work. So we created a context with a custom hook to do all those functions that go and do all the gedcomex stuff. And we put it in our context. We had a use memo that would only change when the data that caused it would need to change. And so it all happened in one place and it all happened at once. And so when it was time to change the implementation details, we could do it all together in this one context. And it was fast. I've talked to people who said, React is so slow when you're dealing with big data and stuff. And it's like, and context, like I hate context. It's like, no, if you do it right, it's actually really fast. So it can be done really cool and really fast. Context can be scoped and used really effectively. Okay, so that's solid. That's what I've got for solid. I'm going to go a little bit through component principles and then clean architecture. I'm just doing a little bit because I don't want to like take too much of your time. I don't know how bored you are yet. The first thing I want to talk about is choose your heart. It's a balance. You can't do absolutely everything perfect all the time because then it would take 1,000 years to build anything. But you can choose what you want to be simple and what you want to be hard. Do you want it to be hard to reuse it or change it? Do you want it to be hard to understand? Can you get all of the above? Maybe. And maybe you can negotiate the time for it. My favorite method when I'm asked to move fast and break things is that, okay, I can move fast and break things. And then when I go code it, I just take my time and do it right because I'm moving fast because it's going to take way longer to fix all the problems once you've done it wrong. So that's my method. Manage your releases. Avoid breaking changes. If you can't avoid them, try and make them less painful. You can do code migrations and code mods. They're amazing. They're awesome. Maybe we reach for them too much. Maybe we use them as just an easy way to get out of. We can say, oh, it's okay to make breaking changes. It does make it a little easier, but we still want to avoid them. Follow version rules. Don't put breaking changes in a minor version file just because it's convenient. Have your change log and know that, and be able to tell people when you're going to break them. Avoid cyclical dependencies. Allow no cycles in the dependency graph. Changes to the dependencies in a cycle causes a lot of developer pain, and the larger the cycle, the longer it takes to make a breaking change when you have to make a breaking change. And so when you breaking the cycle to stop the madness requires a lot of thought and discipline, but it's worth it. Stable dependencies matter. So this is an example of role indicator has a package JSON that has root, and it puts something from Zion root in it. Role indicator has very few changes, but root has lots of changes. And so we have a rule internally that if the things in the package JSON have a breaking change, you have to make yourself have a breaking change. It's lazy because half the time that thing that was a breaking change in the dependency didn't actually break you, but half the time it did. And so we just say, rather than accidentally mess up the one way, we mess up the way that doesn't hurt as much or cause problems or outages as much. But a component that's normally stable becomes less stable when it depends on a volatile component. That's one of the big things in the component architecture from that book. And it's true. The more you think about it, if you think about your dependencies, I think you'll find that it's pretty true. So putting it all together with clean React architecture, leave your options open. Use cases, teams, and requirements, they change over time. Your organization's unique. You have unique challenges. So make your system easy in all the ways it must change for your organization, and do your best. And so this is the kind of thing that AI isn't going to figure out for you. Just this is a really good thing to master because this is going to help in your career and help in, because when you build something that's really good and really strong, it's it helps your company move fast, right? And you'll be noticed for it. Many changes will benefit from having a clean architecture, but say you have a major central database change, or you have to make it so you can work with any kind of database. And if you have encapsulated that system, it's easy to make that change. Let's say your startup spot out and you need to make a branding change to match. If your system is built in a way that's easy to do that, it can just be redone quickly and easily. When you have a major stack migration, like going from Create React app to server-side rendering, if you have a clean architecture, less is going to have to change. And there's lots that you don't know about that's going to come in the future. So why do we have to do all this extra work? With practicing care, clean work doesn't extend development time because it actually makes it faster. Apps and libraries can grow as needed, and they can change as needed in ways that don't require full rewrites. And then we'll spend more time working on new things and less time managing our mess. The books, I have them here. I brought them if you're interested in taking a look at it, but I have some links to some of the resources I found and some of the things that I got from this presentation here. And I've got a QR code if you look on my presentation. So I'm happy to answer any questions, or if you have any suggestions or anything else. I guess I can keep it up through the screen.
Yes, we have a question.
Yes.
So, if you work on a platform, so many people are going to consume your code. But let's say you don't have access to all of their repos, or you're just not aware of every team that uses the platform. Do you try to make a perfect code mod, or one that's good enough knowing that you can't really test it against and how you use it? Like, hey, if it works, it works. If it doesn't, it's better than nothing.
I would make my best effort. I would do a 90% effort, and then I would make my contact information clear. And if somebody gets really stuck because that 5% or 10% is really affecting them, then I'll do that work. That's the way I would do it. Anything else?
How do you, on your team, how do you mitigate marketing, adding a bunch of stuff, like marketing or search engine optimization? Like how you explained it, it's very tight and concise,
Right.
but that's as you do it, not as other. So actually,
Yeah.
rephrase it. How do you stop other teams from adding more to what you have?
My answer is that you build it so you don't have to stop having teams add more to what you have. Honestly, if you, let's say, some of the things we've had to do in the last year was add a marketing system, the marketing bot, without telling us. And then they said, put it on the website. And we was like, are you serious? So we had to do that. And we did it. We wanted to keep our jobs, right? So sometimes you got to do what they tell you to do. And then sometimes you can say, I know this like product page is really good as it is, but I also know the SEO team is going to want to tweak the title and tweak the text and A/B text test all of it. So we just build it in, if you can have a CMS that makes it so that they can go play with it, let them. I really don't enjoy when you give them a WYSIWYG to just ride over like Adobe Target does, just ride right over anything you want. And it's harder in React. It's better to say you can't in React because they just are going to change all your selectors for you. Sometimes that's what is going to help the company is to not just say no, but rather to say, let's see how we can solve this problem together in a way that isn't going to make me change this code every day.
Yeah. Makes sense. Thanks.
Yeah. Any other questions, thoughts? Well, thank you so much for letting me come and talk to you today. I just